So, retrieval augmented generation, or RAG, is mostly hype right now. And I'm not just saying this lightly. I say this as somebody that's been working as an AI consultant in the field now for a few years, and also somebody that has developed their own AI products. And I will say with a certain amount of confidence that right now, retrieval augmented generation is mostly hype and does not work well for most production use cases. I think part of the success of retrieval augmented generation in generating that hype around it is because it was originally designed to solve the problem of hallucinations with large language models. But another factor is how easy it is to develop a prototype or proof of concept using tools or intermediaries like LangChain or even Llama Index, and combining that with the vector databases that are available now, and they are pretty ubiquitous. Saying all of that, what I have found is that I have a lot of clients coming to me with use cases, and often the use case will involve some kind of RAG pipeline. And because they have been able to develop a proof of concept, or maybe they've seen something that works, a demo, they believe that it's going to be easy to apply it to their own domain. And it's at that point that I usually have to turn the work down or provide them with a more realistic alternative because, as I mentioned at the start of the video, retrieval augmented generation right now is mostly hype. Now, I'm not just going to make these assertions without backing them up or giving you some details. So I will proceed to go into a bit more detail about why I believe it's mostly hype. As always, if you think differently, feel free to comment in the comments to this video. It'll be interesting to know your experience with retrieval augmented generation in production and if you've had any success. I'll say I have worked with legal companies, I've worked with hospitality, I've worked with social media companies, all wanting to implement some form of retrieval augmented generation into a product. And most of the time, it hasn't worked well. I'll say the caveat on that is when you look at the massive AI companies. So I'm talking about the OpenAIs, the Perplexities. Those guys are the only ones that have managed to actually implement retrieval augmented generation successfully. And the reason for this is pretty obvious. They have massive amounts of funding. But I will go into more detail about this, and I'll talk about my experience building products with RAG. And hopefully you can learn from some of the things I've already picked up. And like I said, I'd love to hear from you in the comments if you feel different. Before I get into the technical details, if you're not already a subscriber to the channel, please subscribe to get more insights on all things artificial intelligence and large language models. Okay, so the first thing is about hallucinations. And this is my first kind of bugbear with retrieval augmented generation. As I mentioned in the intro, it was initially brought in to solve the problem of hallucinations with large language models. So we know that large language models are trained on a set of data or a corpus of data, let's say. And once that model is trained, those weights are pretty much fixed. It only knows factually what it has been trained on. So if there's an event that happened, for example, let's say an event happens in 2024, and your large language model was trained on data from 2020 to 2023, let's say. So it doesn't have any data about 2024. If you ask it a question about an event that happened in 2024, it's not going to know the answer to that for obvious reasons because it's not in the training data. And that's where retrieval augmented generation comes in. The idea behind that is you can have that context separately and use retrieval to bring in the relevant context into your large language model input. Therefore, it has access to that context and can answer the question factually. I've done some videos previously explaining how retrieval augmented generation works, and I have some articles on Medium. So if you want to get into more detail about how retrieval augmented generation works, I will post a link to those articles in the description to this video. But basically, it can help with hallucinations. Now, here is the issue. It does not get rid of hallucinations 100%. And there are several reasons for that. But the one I want to talk about in this section is to do with the contradiction between the weights and the retrieve context. So for whatever reason, sometimes when you build a RAG pipeline and when you query that RAG pipeline, so you ask a question, even though it's retrieved the right context, the answer it responds to can still be hallucinated for some reason. It could be completely wrong answer. And my theory behind this is because maybe the question you're asking, the network has been trained on one thing. So the large language model has been trained on one set of data that provides a contradictory answer to the context that you have retrieved. So sometimes the model doesn't know which one is the right answer, and it's just responding based on the probabilistic tokens that it returns. And that can be a big problem. And what you find in production is that this might not happen even for the first 100 queries, but you get to 1,000 queries and you start to see this happen more and more. So the hallucinations become more voluminous with the number of queries you have. And if you are doing something in production that needs to be right, so you don't have any room for hallucination, like if you're working with, for example, a legal assistant, that can be a big problem. To take a look at what I have on screen here. So this is the GitHub repository for LangChain, and this is specifically the RAG chain element of LangChain. So this is a ready-made RAG module for those of you that want to do retrieval augmented generation and you're using LangChain. If you haven't dug into the source code of LangChain or any of these other intermediary type tools, I recommend that you do, because there are quite a lot of things in there that I think are surprising and some things in there that are useful for you to know. But essentially, they have their own prompt in here for RAG. And what you can see is when you look at the prompt, you are an AI assistant, answer based on the retrieved documents. And then you have the context here. So this is where the retrieved context goes in. So they need to specifically tell the model to answer based on the retrieved context. Now, depending on what model you use, it might follow through on this and answer from the retrieved context most of the time. So the more powerful models like GPT-4 will probably be better at doing this. However, if you are planning to use smaller open source models, some of those models, for whatever reason, sometimes do not follow the prompt in the way that you want them to follow. So that's where these contradictions can come in as well. Rather than answering based on the retrieved context, the model can get confused and answer based on the weights that it was trained on. So this is something to be aware of. Do not buy into this myth that RAG solves all of your problems for hallucination. It gets part of the way there. It's a part-way solution, but inevitably there are still going to be hallucinations. All right, we've covered the hallucination aspect of RAG, which there is. Now we must talk about the retrieval aspect of RAG, because of course RAG is retrieval augmented generation. So part of that is a retrieval process in which we're trying to find the correct context from a knowledge base. And then the other part is obviously the large language model generation part, where we feed that context into the input for a large language model to generate our response. The retrieval part for RAG is difficult in production. And here is why. And I think this is a non-obvious thing that people find out only when they're starting to build for real use cases. I have partnered with people building RAG chatbots for hospitality, is a great example. So when they've been building these RAG chatbots for hospitality, all of a sudden they've realized, hold on a second, the information we're getting in here is not uniform. We have to pull information from the website, for example. So it might be a hotel website they have to pull information from. There might be a restaurant and they have to pull some information from the restaurant menu. There might be, I don't know, some other amenities in the hotel and they have to pull information from all of these disparate sites. And often that information is scraped from the hotel webpage or whatever, the service webpage. But other times that information actually can be in a PDF or in a Word document or wherever, in an Excel spreadsheet sometimes, or CSV. Now, the format of the document isn't really the main issue here. There are ways to deal with the disparate formats. It's actually the form itself of the document. And what do I mean by form? So if you look at a menu in a restaurant, it's written in a specific way You have very short paragraphs describing either the drink or the dish available, and then you have some price associated with that. Whereas if you are going to the same restaurant, the same web page, and you looked at the about page, you're going to have much longer paragraphs detailing, various things about this restaurant and, why you might want to come and eat there, its history, its founders, all of that type of stuff. So what we're talking about here in real production use cases is you are often having to do RAG over documents that are non-uniform. They are completely different in form. An about page is going to be very different from the menu of a restaurant. Now, why is this a problem? It's a problem because in the retrieval part of your RAG mechanism, one of the first parameters that you need to decide on is the chunk size. So how are you going to break these documents down into chunks to store in your vector database to later on retrieve? And the way you chunk the document does have an impact on the accuracy of what you retrieve. And what I mean by accuracy of what you retrieve is, are you actually retrieving the information that you need to retrieve? The way you chunk those documents has an impact on that. And here's another thing. The type of document you have, so what it's actually talking about, the structure of the sentences and paragraphs and all of that type of stuff also impacts the optimal chunk size for those documents. So you imagine in a production use case, you're going to have various different types of documents, like I just described to you there, about pages, menus, hotel amenities, descriptions, all of those types of things in a production use case. Now you have the challenge of deciding, wait, how do I chunk for each one or each type of document? And these things are constantly changing. They're constantly in flux because you have people updating things. Prices change, things change on the about page. So these things are constantly in flux. If it's a different person writing it, the writing style might change as well, which might also impact the way you need to chunk your document. So you have something that has lots of moving parts, and it's not clear how to actually set that chunking parameter so that your RAG pipeline is set up to actually retrieve the context in the most efficient way. And that is a problem I have seen throughout the RAG use cases I have been exploring and building with clients. And there's not really any straightforward way to solve that. Another issue I commonly see with RAG implementations in production is that they are often prohibitively expensive. Now, I have worked with clients that have put RAG solutions into production. They've turned these into products, and they even have some users. So they might have a few dozen users to a few hundred users. But those clients start hemorrhaging money because what they realize is they haven't done the pricing up front, and they haven't quite calculated exactly how expensive it is to do RAG. And it was the case that I had a particular client that was in a lot of trouble. They had recently secured some investment, but they found they were running for it. The burn rate was high just to fund this RAG model that they had been relying on as the central feature for their product. Now, to understand why RAG is expensive, I think it's best that I pull up an example on screen. So we'll first look at an ordinary chatbot and how that might work, and then we'll go on to the RAG approach, and you can see why the cost for RAG starts adding up. So I'm going to show you a dummy conversation that I've set up, and this is just using a normal chatbot approach. So a normal chat assistant that you might have. And for this normal chat assistant, you'll want to have some kind of memory. You want to have that memory so conversations can have some continuity to them. Nothing worse than chatting with an assistant that doesn't remember the last thing that you said to it, right? So this is what something like that might look like. It will say something like, hi. You'll say something like, hi, I'm Dave. It might respond, hi, Dave. You can say something like, do you remember me? Yes, Dave. And that demonstrates that this type of chatbot has a memory to it, right? Now, look, this is without RAG, just as an example, just to show you what a standard type of chatbot might look like. So let's go on to look at the prompting scheme. So what we have here is we have a prompt, an input prompt, and it's relatively simple. If you built things in OpenAI before, you'll recognize the system prompt. So the system prompt guides the overall behavior, or it's supposed to guide the overall behavior. And then you have a chat history, and that's where the conversation history comes in when it exists. And then you have a query, and that's the input from the user. So this whole thing is what you input to the large language model. And obviously, largely, this is abstracted away from the user. So they don't see this. They only know what they input. And then you get the response, "Hi, Dave." Now let's move on to the next slide. And you can see now, notice the input has grown. So I think in the last slide, it was around 22 tokens. We're up to 28 tokens. And that's because now we have the history of the last interaction in there. So the chatbot has a growing memory. And obviously you can decide how large you want this memory to be, but you should know that every time this memory increases, you're going to increase the size of the input tokens to your large language model. And then you have the query here. Do you remember me? And of course it does, because it's in the context. It knows that you are Dave. All right. So what you should understand, if you don't already, is that when you're using large language model services like OpenAI, you are charged for the number of input tokens that you send to the model, as well as the number of tokens that you ask the model to generate on the other side. And the input tokens, if you're using any kind of assistant, you want to have a memory aspect. So your input tokens are going to grow as the conversation length grows. And obviously there will be a limit, an upper limit to that, based on how much memory you allow. And when I say memory, I mean the conversation history. Now you might think, okay, if I use an open source model, this doesn't matter. It does. It matters using an open source model, because you're asking it to process a larger input, which also requires more memory. So that might mean that you need higher memory, higher RAM GPUs, for example, to process that input. So it does matter. Either way, it's going to cost you more to process more tokens through your large language model. Now let's look at how that changes when we use RAG. So here's a standard RAG approach that you might take. So somebody might say, what wine is on the menu? And the bot will look at the menu, will look at the context of the menu, and it will say, we offer Pinot Noir, Pinot Grigio. How much are they? 7 for either. Okay. So this is obviously information that the bot has gotten from the menu, or the large language model has gotten from the menu. So let's look at the prompt to understand the context. So rather than just having the history component, now we also have the retrieve context in there. So you might be ahead of me in understanding this, but for those that haven't caught on to this yet, what's going to happen, obviously, is that we're going to not only grow this history, but the retrieved context is going to grow too, because we're going to always be adding that context in. And depending on what query we ask, that context could be, it might be a small context, or it could be a large context. So we're always, the initial prompt is much larger, or the average token input that you ask the model to process is larger for RAG applications than it is for just your standard chatbot without RAG. So you can see here the input tokens are 49 tokens compared to, I think it was, we said 28 on the last slide. So let's have a look at how that grows. So that grows to 64 input tokens, because we have the previous conversation here, the chat history, and we have some retrieve context here, because we've asked how much, so it needs to retrieve that context to understand how much it is. And then we get our answer, 7 for either. All right. So hopefully that is clear to you why there is going to be an expense, why RAG is expensive for production use cases, because this is a really simple use case. We're just talking about a few items on a menu, but for production use cases, if you think about something for a legal chatbot, for example, you are retrieving quite large context, and it could be quite complex stuff. So every query is going to be really large in terms of the input tokens. Everything is going to be huge. Now, a lot of people don't understand this, because especially people that are coming up with the product managers, for example, that come up with the ideas for these RAG chatbots, they only see this. They only see this query, but they don't understand that also the input is all the stuff behind the query. So all the prompting that is hidden from the user. And that's what causes RAG to be expensive. Okay, so before I finish up, I want to talk about two things that I believe need to happen before RAG actually becomes practical to use in production. So the first one might be rather obvious, and that is that the cost of hardware needs to come down. So the cost of hardware coming down would mean that queries to large language models, services like OpenAI or Mistral, whatever your choice of large language model you want to use, should also come down. So those input tokens, you'll be getting charged less and less as the cost of hardware comes down. Right now, in artificial intelligence, we have a shortage of GPUs, and that is pretty much because NVIDIA has pretty much a monopoly on providing the type of GPUs that you need for processing data with large language models. And not only the GPUs, they provide the compute platform too. So until there's more competition in the market and until we can get more alternatives, we're going to be prohibited. We're going to be limited economically in the types of products we can develop with large language models because of the expensive hardware required. So the cost of hardware needs to come down to make these RAG type use cases work for many more production use cases. So that's the first thing. The second thing that needs to happen is that the language model capabilities themselves need to improve. Now, this might be by training more powerful models or by taking different approaches to training the models. So something that I've heard someone suggest before was that why aren't we training or fine-tuning large language models specifically for RAG? So you saw the input context that I showed you for RAG. So we could actually have that as a training example and the expected output and train the model on RAG itself instead of having the model trained normally on some kind of instruction tuning and then expecting it to be able to perform RAG tasks. We should just train it on RAG itself. And that might improve the performance and might even get rid of that initial hallucination problem I was talking about where the model gets confused between its weights and its RAG task, let's say. So those are the two things I think need to happen before we can get RAG into production. But until then, I would say to you, the lesson is really don't get carried away with RAG. Don't get fooled because it's easy to build prototypes. It doesn't mean that it translates well into your production use case. Think about the pricing element to it and think about how accurate your results need to be. If it's something that you cannot afford to make any mistakes, I would consider another approach. If it's something that you can afford to make some mistakes, I would still consider some kind of sense check on top of the results. So if you can, for example, provide links or sources to where the RAG model is pulling the information from, or if you can provide a curation layer on top of your RAG model to make sure that nothing is being cited or nothing's being generated without a source cited, that could help as well. But all of these additional features are obviously going to increase the complexity of your application and also the cost. That is it. And if you enjoyed this content, subscribe to the channel for more, and I'll be releasing more insights on artificial intelligence and large language models for real engineering use cases. Thank you for tuning in once again.